Hello everyone, my name is Himal Patel and in this tutorial I'm going to show you how to output 10 MHz of continuous signal which has been derived from the onboard clock oscillator of 50 MHz. So the first thing I'm going to do is show you my code for this program. So this is the code for the program, and in a nutshell what this program is doing is creating a clock divider. So our input frequency is 50 megahertz, and then it's lowering that frequency and then outputting 10 megahertz of clock frequency. So I'm using a counter to do this. This is the test bench for my previous program. So this test bench, as all the other test benches, are basically intended for making sure that my program works as I intended to work. The next thing I'm going to do is go to Model Sim and show you the actual demo of the input frequency compared with the output frequency. As you can see, my files are already loaded here. So what I'm going to do is that I'm going to compile them all. So when I compile them, on the bottom of the screen, both of the files compiles fine with no errors. Then I'm going to hit simulate and start the simulation process. I'm going to choose the correct test bench, which will take me to the actual simulation page. So I'm going to grab the signals here that I need, and for reading easily, I'm going to rename them. So this is the input signal, this is the output signal, and lastly, this is the reset. Alright, so once I have that done, I'm going to go ahead and run the program. Now I'm going to stop it. So I'm going to scroll back all the way to the beginning of the program and zoom out a little bit to get a better view. So as we can see, when reset is high, the output clock frequency is 0. But as soon as reset goes low, at the next rising edge of input frequency, I also get output frequency. So if we take a cursor and let's see, put it here as the first rising edge here, and then add another cursor with this. So add a cursor just right at the another rising edge. We can see that is approximately 20,000 picoseconds. So if we calculate the frequency for this, we should get 50 megahertz of frequency. Now if we move the cursor from here to all the way here, which is the 1 clock cycle for output frequency, we can see that is almost 100,000 picoseconds, and if we calculate the frequency for this, we get 10 megahertz of frequency. And this is just this continues, it repeated, goes on and on, as you can see on the screen. So this is my demo of showing you outputting 10 megahertz frequency from the given input 50 megahertz of frequency. I hope you guys enjoyed the video, and thank you so much for watching.